In this section, we're going to learn how to solve one-step inequalities. So first of all, solving means we need to find a solution. So a solution set of an inequality is the solution. So the solution of an inequality with a variable is the set of all numbers that produce true statements when substituted for the variable. So with equations, we usually only have one correct answer. Inequalities, there can be infinitely many correct answers. So let's learn how to solve inequalities. This is a property that's always going to hold with inequalities. So it's called the addition and subtraction property of inequality. Adding or subtracting the same number on each side of an inequality produces an equivalent inequality. Now this is identical to the way we add or subtract to each side of an equation to get equivalent equations. So let's look at, we're going to skip over the algebra part. We're just going to look at some examples. So it says solve an inequality using subtraction. So I have m plus 5 is greater than or equal to 10. And I need to graph my solution too. I can't forget to do that at the end. Now, if this were an equation, I'd have m plus 5 equals 10. And you would all know it's addition, so do the opposite of addition, which is subtraction, and subtract 5 from both sides. We're going to do the same thing with an inequality. Subtract 5 from both sides of the inequality. So I end up with m. I'm going to keep the sign the same. 10 minus 5 is 5. So that's my answer. Now to graph this, we're going to do what we did last section. Draw a number line. 5 in the middle, 4 and 6. When I have the or equal to sign, it's always a closed point on 5. Now I want all the m's to be shaded that are greater than or equal to 5. So greater than means right on the number line. Shade to the right. All right, and we're done with part A. This one says 14 is less than a plus 9. All right, I am again trying to get a by itself, just like I do with equations. So right now it's a plus 9. So I need to undo that addition by subtracting 9 from both sides. 14 minus 9 leaves me with 5. I get 5 again, is less than a. Now I need to be careful when I'm graphing this. I'm going to put 5 in the middle again. I know it's an open circle because it's less than. Less than or greater than is an open circle. I like to think of it as it's less work to not do the little line beneath. So it's less work to, we don't have to shade it for when it's open. It's a little trick. It's more work to do the or equal sign. It's more work to shade it in. So those two go together. Now, be careful because although this is pointing to the left, I actually have to shade to the right because my variable doesn't come first. I can only use that trick when my variable comes first. So I'm going to shade to the right because 5 is less than all my things that I shaded. So 5 is the very least. Everything else that I shaded is bigger. And there I have it. Okay, let's try using addition. So now I have negative 8 is greater than x minus 12. Again, I want to get x by itself, just like I do with equations. Right now I'm subtracting 12 from x. So to undo that subtraction, I'm going to add 12 to both sides. Negative 12 plus 12, that's 0, so that can go away. Now I have negative 8 plus 12, that's 4. Bring down my inequality sign. So 4 is greater than x. If the shading confuses you when the variable doesn't come first, this is actually the same as x is less than 4. If you were to flip the two things around on either side of the inequality sign, and you also flip the sign, that is an equivalent statement. Kind of like this is the same as a rather than less than is greater than 5. Those two things mean the exact same thing. Okay, so I solved this. Now I need to graph it. So I'm going to put 4 3, and 5. Okay, so 4 goes right here. It's an open circle. And now it might be easier to look at this statement. It's pointing to the left, so x is going to be less than 4. So I want all my solutions that are smaller than 4.